All right, everybody, what I want to do today is to wrap up the simplification demo that we started in class and then we found some technical difficulties with. Uh, and that is, we will also cover how to acquire spatial data. All right, so we saw naturalearthdata.com, okay? So in many cases, you will not be given the data you need, especially in other courses and later in your geomatics career. So you need to go out and find that data. I want to show you one of the most handy tools for getting basic shapes. Okay, so we're talking about vector data here. They also have raster map data at naturalearthdata.com. But for our purposes right now, we will be working with vectors. Okay, and I want to show you one resource for downloading some very basic political boundaries as well as the location of cities. Okay, so naturalearthdata.com, click on downloads. We have three different options here. Okay, so we have the small scale data, suitable for really zoomed out views of the world. Okay, so showing continents and showing the entire globe. All the way over to large scale data, so something a bit more zoomed in with a lot more detail. Okay, and for our purposes and for the intent of the map I want to make, I want something at the global level. But I'm going to go ahead and download the more zoomed in stuff, the more detailed map data, so that I can show you how to simplify it. Okay, so you can see here that our scales can be 1 to 10 million, which essentially breaks down to 1 centimeter on our map. It's going to be 100 kilometers in reality, in real life. Okay, so that's the scale. We'll talk more about that next week. We want cultural data because we want the outlines of countries. And in fact, I actually want the outline of the states and provinces. So I'm going to go ahead and download this. And this is going to download as a zip file, okay, which is a compressed version of our vector data. Okay, so this is exactly what you did for the first part of lab in the tutorial, where you downloaded a set of shape files for New Mexico and for the forest and lake and roads. Okay. In the meantime, while that's downloading, I'm going to load up Map Shaper. So this is how we're going to edit our map data in a way that's much more convenient than in ArcGIS, to be completely honest. Okay. And so the way this is going to work is we're just going to drag in our zip archive, that is our zip file here, which is going to consist of a shapefile, and it's going to load things up for us. It's a large file since there's a lot of detail. Okay, it's as we'll see, there's a lot of detail on the map, meaning we have a lot of vertices, and the file size is just generally larger than. Okay, you can see that there are different components to the zip file. There's the actual shapefile, the projection document, which we will cover next week, and the database. Okay, so we will import that, and there we are, the states and provinces of the world. Okay, so we can zoom in and see some of the detail here. And, you know, if we wanted to zoom in and create a map of the Pacific coast, this would be great. There's a lot of detail here. However, I actually want to make a global map of the states and provinces. Okay, so I don't actually need this much detail. Okay, it's a little too much. So that is why I'm going to simplify. So this is the button I was looking for earlier that the screen wasn't giving to me. This button here just tells us a little bit about the file. We can add even more layers so that we can see how they simplify, the different layers simplify together. We know that this has 4,500 polygons or shapes in it. Okay, but this is the button I was looking for. So this gives us, this is where we have our options for how to do the simplification. Now, this is why we covered the different algorithms or rules earlier, so that we have a high-level understanding of what these different methods do when we apply them. I do not expect you to memorize the details for each one, but I do think it's your responsibility to understand at a very high level, again, how these different methods work. That way, when you are applying them to real-world situations, you have a sense of what's going on behind the scenes. Okay, so in this case, we're going to choose to prevent any shapes from being removed. Okay, we want to make sure all the states and provinces are there. We are also going to apply the Douglas-Picher method. Okay, so as you can see, that algorithm is not just something obscure thing in the textbook that I decided to show in class today for no reason. It's actually one of the more common methods for simplification. So we'll apply that. And when we click that, we get some options up here. Essentially an interactive slider for determining how many points we want to keep on the map. And again, remember, points or vertices are just, they are what define lines for us. So the fewer points we have, the more coarse our lines will be. Okay, so if we retain 50% of the lines, or points, excuse me, we are going to have coarser, more generalized features. Okay. So this is essentially changing, when we interact with this, changing our tolerance measure. Okay, so let's go ahead and play around with this. So we can see that we select something like 50%. Things maybe change a little. Okay, there are some line intersections, some topological errors, which we touched on briefly, that had to be repaired, okay, because those shapes had lost a bit too many lines. But in general, you can see that we still have a lot of detail here, even though we've removed 50% of the vertices, okay? We can go even further here. So what if we retained 10%? Okay, still a lot of detail, pretty sufficient for our purposes. What if we even go down to 1%? Okay, now we can see things are a bit more blocky. In general, though, they give us a good picture of the states and provinces of the world, sufficient for our zoomed-in view. But if we were to zoom in on, say, the Pacific coast again, that would not be a pretty map. Okay? So you can see that depending on our scale and purpose, different levels of detail become more or less important. Okay, so for a map that's zoomed out, at the global scale like this one, we can actually simplify our data down pretty drastically and still have a nice looking map that accurately and honestly beautifully or appropriately displays our data. Whereas if our map purpose was something that was a bit more scaled in and a bit more focused on, say, the provinces and state of the Pacific coast, this map would not, this level of map data, this amount of detail in the map data would not be sufficient. Okay, we can go ahead and export this data as a shapefile. So I'll export our view here, and we can load that up in ArcGIS. Okay,